Welcome to Chapter 7. Now let us continue with exercise solubility. Okay, so calculate the solubility molar. Okay, solubility molar means we are going to find X of silver sulfate at 25 degrees Celsius and then given KSP. Okay, then the first one is we want to find it in water. Okay, meaning that, okay, now we will start with number 1 first. Okay, meaning that in the solution, we have silver ion and we also have sulfate ion, and then in water means water dissociate, we will have H plus and OH minus. Okay, so when we look at these 4 ions, there are no common ions. Okay, when there are no common ions, means that we don't have to start with the initial. We straight go to equilibrium. Okay, so now we start with silver sulfate. Okay, remember, if given solubility means this is a slightly soluble salt. Okay, so it is solid. Okay, then if you cannot remember the ion, it's very easy. Silver. Okay, so if we want to get 2 here means 2 negative. Then this one is 1. So this means this is positive. Okay, so silver positive equals plus sulfate ion. Okay, and then don't forget to balance 2 for silver ion. Okay, now we move on to the next one. That is, we calculate the molar solubility at equilibrium. Okay, solid concentration constant. Okay, so this one will be given is 2x. Okay, then this is x. Okay, so what we going to do now is write the expression for solubility product, that is silver square, then SO4 2 minus. Okay, then when we substitute at equilibrium, it is 2x square x equals to 1.5 times 10 to the power of negative 5 as given. Okay, then we continue with finding x equals to 0.0155. Okay, so rewrite molar solubility is 0.0155. Okay, don't forget the unit, that is molar. Capital M, or you can write mole per liter. Okay, so this was number 1. Okay, now we go to number 2. Okay, number 2 says that silver sulfate ion in solution of silver nitrate 0.1. Okay, meaning that, okay, let's say now I have the second one. I have silver sulfate and I also have silver nitrate. Okay, so when we look at here, there are 2 ions that are the same. So it means that we are going to have common ions, that is silver. Okay, so again, same thing, start writing with the dissociation of slightly soluble salt into its ion. Okay, but this time, just now when in water, there is no common ion. So we straight head to equilibrium. Now we have common ion, okay, and then it's 0.1. So means initially, silver ion has concentration that is 0.1 molar, which comes from silver nitrate. Okay, then changes minus 2x, remember. Okay, so this is plus x. So at equilibrium, we will get 0.1 minus 2x and then x. Okay, same thing again, substitute into the solubility product expression. Okay, so KSP just now given is 1.5. So we have 0.1 minus 2x squared times x. Okay, if you don't want to solve in quadratic way, we can say assume KSP is much less than 1. Thus, 0.1 minus 2x will be equals to 0.1. Okay, then we can find our x. Our x will be equals to 1.5 times 10 to the power of negative 4. Okay, then write down molar solubility is 1.5 times 10 to the power of negative 4 molar or mole per liter. Okay, so here just a reminder. When the question gives solubility molar in water and in another solution, what you need to find is there any common ions? Okay, if there is no common ion, straight head to equilibrium. If there are common ions, then start with initial, and then the concentration of the salt will be initial. Okay, it is the same as Ka and Kb. If the constant is too small, you can do assumption, then you don't have to continue with quadratic. Okay, so that's all for the calculation part for common ion effect.